Okay, so it's the 12th of May. So we're doing VLANs and Inter-VLAN routing, so modules 3 and 4. Next week we'll be doing spanning tree and ether channel. And so, of course, spanning tree stops switching loops. Switches do not handle loops very well without it. And ether channel is a way that you can sort of get some redundancy and some extra performance with very little downside. Yeah, that's the next this week and next week. So, switches and VLANs and into VLAN routing. So, basically, here I've got a bit of a setup. I'm going to demo legacy into VLAN routing as well as router on a stick into VLAN routing. And of course, I'll define the VLANs as well, which of course is chapter 3. So I'm going to define 3 VLANs, VLAN 10, 20 and 99. They have their own SAMNet numbers. And so VLAN 10 is staff, VLAN 20 is student, VLAN 99 is the management VLAN. And so there is another setup on this side here. And this is a layer 3 switching demo. And so as you can see, one less device, that's always nice. And so we'll end up doing exactly the same thing as this previous one, but probably a lot more efficiently and quickly. So VLANs, so we'll have a look at the switch configuration for what to start with. And so basically, as I said, we're going to have 3 VLANs, VLAN 10, 20 and 99. So VLAN 10, once you, of course, type that into global config mode, we'll actually go into VLAN config mode afterwards. And so, of course, then name staff will be set for that VLAN. Of course, this will then change it to VLAN 20 config mode, and it will get the name of students and so on. So, creating and naming the VLANs.
So I was going to ask, that creates the VLANs. They don't exist before then?
No, these are blank switches.
So VLAN 10 creates that VLAN?
Yeah. You don't have to name it because it will have VLAN 0010 or something as a name, but I'm saying name is descriptive and helps later. So that's enough to create the VLANs. Of course, they're not much use unless you assign the VLANs to an interface. Now, because I'm doing legacy first, that's why there's 2 links between the router and the switch. The one on the left is the VLAN 10, the one on the right is the VLAN 20. This router's only got 2 interfaces, so VLAN 99 misses out. You got a question?
Yes. What about this?
Yeah.
Every time I go to results, it's saying my hostings are wrong.
I don't care about that.
Okay.
Just go through the checklist. If everything works on that checklist for the past testing, be happy. I'm not using the scoring. All right, so of course, as I said, you need to assign them to VLANs, and so this one here is actually the link up to the router, and so it's switch port mode access VLAN 10. The other one is actually this port here. That's actually fast Ethernet 01. It's only got 2 gigabit ports, and I wanted to use the other one for this link here. And so that's again switch port mode access, and then accessing VLAN 20.
So are you on the switch right now or are you on the router?
Oh, I'm talking about the switch.
So you're plugging this into the switch?
Yeah. So, and then G0, as I said, that's the trunk link between the 2 switches. Now, port 10 conveniently is going to be a member of VLAN 10. And port 20 is going to be a member of VLAN 20. And so that will, assign that, and that's what these hosts are connecting into. So that should be port 10 there, if I select it. Yeah, that's 10, and that's 20.
And what's 1 doing then?
1 is the link up. That's the second link for this legacy into VLAN routing.
So access is host facing and trunk is other switch facing.
Yeah. And so, of course, I'm going to set up a switch virtual interface so I can manage it. So that's pretty much it for switch 1. Switch 2, we've just got this trunk port, which of course is that one there, and then the 2 ports for the hosts. And of course, we need to define the VLANs on switch 2 as well. So that's done. And we've got the SVI there. So let's paste this first one into switch 1. See how that goes. That's right, shortcuts don't work. So I don't see any errors. So it's all good. So we can do show VLAN. That's why I'm not a secretary. Okay, so of course on this first switch, we've got the port that points to the host for VLAN 10. We've also got the uplink to the router for VLAN 10. And so for VLAN 20, we've got the uplink to the router and we've got the link to the host as well. So VLAN 99 is there, but it doesn't have any ports assigned to it. And another thing you'll notice is G0/2 is not on the list because it doesn't belong to any VLANs because it's the trunk link. So let's show VLAN. If we do show run, we'll see where all this stuff went. And so you can see the port assignment for port 1, port 10, port 20, and the 2 gigabit ones. That's the trunk to the other switch. That's the uplink to the router. And so here, of course, we've got the SVI configuration.
So those numbers 10 and 20 and 99, or 10 and 20 in particular, those are the important numbers, right? Like PCs connected to other switches will need to have the VLAN set to 10 or 20
yeah.
to be able to communicate.
These two hosts should be able to talk to one another because this is on VLAN 10 and as is this one. Not that I've configured that switch yet, but once I've configured the switch it will. It's on VLAN 1 at the moment. So let's get switch 2 configured as well. Pasting in, don't see any errors. So again, VLAN 99's up. Show VLAN without the typo. So because we've got the trunk link, there's only 3 active ports on this switch. The 2 to the hosts, and then the trunk link, gig 0/2. Of course, it's not on this because it's a trunk one. So again, if we look at show run, so there's port 10, there's port 20, and there's the trunk link. Okay, so that's actually the VLAN setup on the switches. So this PC actually should be able to post the other PC on the same VLAN. Ping, did I say? 192.168.10.11 is itself. Trivial, but yeah, okay. 12 is the same host on the same VLAN, well, a different host on the same VLAN, but on a different switch.
So if you ping the other PCs, you won't.
You'll get nada because it can't even talk to its own router, let alone the other VLANs, because yeah, the router's links are red. So we're just going to get a very slow timeout because yeah, it can't talk to the router. All right, now the router itself. Did I go through this with you? I don't think I did. Have you emailed that to me?
Yes.
Okay, cool. So this is how we've always done the interfaces so far. So there's no big surprises so far. 1 port, 1 address. There's only 2 ports available, so only 2 addresses. So if we do that, copy, paste, no errors, no problems. The 2 interfaces are up. So if we show IP route, we've got VLAN 10 and VLAN 20. They're all good. I'll just fast forward it through the spanning tree pause. All right, let's do an up arrow, see if we can ping that other host on the other VLAN. So, of course, there's an ARP request or 2 that need to happen. but away it rolls. So that's actually the host on the other switch on the other VLAN. This is the host on the same switch but on a different VLAN.
So this is still in legacy?
Yes, still doing legacy.
So the setup on the router is really simple for the legacy one, except that you need a physical switch.
You need to have lots of interfaces if you need lots of VLANs.
Every VLAN,
Yeah. So that's the major downside. We can't ping the switches. Even though this switch here is the one it's connected to, it can't talk to it because it's on VLAN 99. And we're not routing for VLAN 99 yet.
SVI is on VLAN 99.
The SVI is on VLAN 99, yes. If you looked at the chapter, it would have said at least once, don't use VLAN 1. Yes?
No, just slightly unrelated, but the exam module like 1 of 4, sorry if you've already answered this, but when is it going online?
Oh, have I not activated them yet?
No.
All right. I think I was probably just waiting until a few more people enrolled, but I'll activate it today.
Okay.
Now, so we'll look at router on a stick. So most of it goes on the router. So you can see here that that was the wrong spot to click. So on G000, I'm actually going no IP address. You've emailed it? Yep. Cool. Thank you. See you later. So because we need to put, I'm going to use that exact same address on a sub interface, and so it won't take it. It won't take it if you've got the same address on two interfaces. Routers don't like that. So I had to go no IP address. Of course, that's the one that's going to have the sub interfaces, so it didn't shut it down. This one, of course, had the address for VLAN 20. I need to use that on a different interface, but I actually don't need that interface anymore, so I've actually got a shutdown command. So G001 is going to go bye-byes for router on a stick. So as you can see here, I'm creating a sub interface. So on physical interface G000, create a sub interface called .10. Now I've named that .10 because it's VLAN 10. Could have used any number I like, but might as well keep them the same. So encapsulation .1Q, of course, what that means is put an extra field in the Ethernet header, that 802.1Q field, and fill in the VLAN ID as 10. So that's what it's doing. So that will arrive at the switch, and the switch will go, oh, this packet belongs to VLAN 10. And so there it will stay. And of course, the sub interface needs an IP address as well. Then of course for VLAN 20, we're setting up this other sub interface, .20. Again, the encapsulation .1Q and fill in an ID of 20. Needs an IP address. Here's the upside to router on a stick. We're creating VLAN 99. Again, with a tag of 99 and its own address. And so straight away, it's looking better. So I'll paste this in and see how we go. It's not the first time I've done it today, so it should go all right. So let's have a look, see if there's any errors. Don't see any. And as you can see, we've got some status messages saying, well, I turned off 001, but 000, 10, 20 and 99 are now up, which, considering a couple of seconds ago they didn't exist, that's all good. So show IP route. And we've got VLAN 10, VLAN 20 and VLAN 99 in the routing table. So we're up. Now, that's good. As you can see, that second link we didn't need, it's down now. Of course, the switch isn't ready for it because that port at the moment is a member of VLAN 10. And the router wants to put traffic for all the VLANs over it. So we need to change the switch a little bit. Yeah, we're just going to make it a trunk. And I'm just setting that back to default. It was VLAN 10. If I make it in VLAN 1, it actually won't show in the config at all. And here I'm doing much the same thing. Sorry. I'm doing much the same thing, but I also don't need it, so I'm shutting it down. And that's the only changes I need.
That first one, sorry, what are you doing with switch for access VLAN 1?
Well, at the moment, it's got switchport access VLAN 10.
Oh, okay, yeah, okay.
I don't really need to do this because I'm making it a trunk.
Yeah, okay.
It wouldn't have mattered anyway, but I'm just putting it back to default just to make it nice and tidy, which is the same as that line there. But really, all I need to do is shut that one down. So we'll paste that into the switch.
So the router on a stick has really simple.
Yeah, just another trunk port, that's all you need.
Setup goes into the router.
Yeah. So fast forward through the spanning tree again. Now, let's try this. Now, of course, I tried 9911, it didn't work. Let's try it again. Again, it's a switch, so it's probably going to be slow up. But anyway.
The switch actually still has all the settings you put in from before.
Yeah.
In legacy mode.
Yeah, all I did was change the settings.
Yeah.
So the VLANs are still there. The host ports are still right. I just changed the ports that needed to be changed. So as you can see, it did work. And so that's actually the switch it's plugged into. The other switch it's not plugged into, let's try that as well. Again, probably slow up. Waiting. There we go.
So you couldn't access the switches before?
No.
Because
the hosts were on VLAN 10 or 20, and the switch SVIs were on VLAN 99.
Okay. But now, because
VLAN 99 is being routed, I can get to it.
So it's actually gone up to the router and then back to the switch?
Yeah.
Okay. And so before you said don't put the switches management on the default.
Yeah, you shouldn't put it on VLAN 1.
Why?
Just because that's one less thing that hackers need to guess.
But before we did VLAN, we were putting switches on. Well, you didn't have VLAN, so.
Yeah, well, you had a VLAN, but it was VLAN 1.
VLAN 1.
So, yeah, well, that was. We were doing that because that was the easiest way to do it. But that's, the easiest way to do it is not the way that you do it in a secure live network. We just had to get to that level.
This is not mainly about security, though. This is more
about
providing a.
Well, VLAN, it does stop traffic between the VLANs, and so there are some security aspects about it. And if we're going to teach it, we might as well teach it in a way that is secure.
There's only like 1,000 VLANs possible. It wouldn't be hard to switch through them and find one that can't. Or but the VLAN is controlled by the switch that you connect to, not by the host. Yeah, okay.
But also there are attacks that the host, if they've got an auto negotiate port. Have you looked at that topic? If they've got an auto negotiate port instead of a static switch port mode access, they can actually turn on a trunk port.
Yeah. Okay.
So.
The auto negotiation says what is the other side of this? What does it be? And so I might change.
And so if you've got that software on a compromised host, you can set it to desirable, and it will be a trunk. So anyway. So yeah, security is something we certainly should be thinking about. It's just that in CCNA 1, we're just getting you through the basics. All right, so I've pinged the two switches. Let's try pinging the other subnets. It's lost its ARP setting, apparently, entry. But there we go. Try the other host. So I haven't broken that into VLAN routing yet, or at all. And let's try the other host on the same subnet, and that's working nicely as well. So, router on the stick is now working. Now, I suppose one thing I didn't do, I showed you the routing table. I didn't actually look at the show run, did I? So show run. Let's have a look at how that looks. Looks a little different. So as you can see, gigabit 000. The only thing you'll really notice is there's the no shut has been applied, so there's no shutdown line, but of course for the next physical interface it does have a shutdown in there. So you need to turn it on for it to work, and of course here are all the subnet definitions here, sub-interface definitions, and so .10, and so it's pretty much exactly how I had it in the config file that I showed you, and the VLAN 20 and the VLAN 99.
With router on a stick, you can access every other PC anyway. So what's the security advantage?
Well, you can actually then put an access control list in there and actually control who can do what. So you like that VLAN 99, you might just permit the one host. So this is our management. This is our network manager's IP address.
Yeah.
He's the only one allowed in there, but he still doesn't need to go to the device to do it. So it's all good. All right, so that's pretty much router on a stick done. Let's have a look at layer 3 switching. So this is the config for the layer 3 switch. Now defining the VLANs, still need to do that. Same as what we did before, no big surprises. Now, of course, when we've played around with switches previously, they've always been a layer 2 switch. And so you've actually only ever had the option of one SVI operating at the same time. Most layer 2 switches, if you do a no shut on a SVI, if there's another one that's open, it will actually shut that one. So automatically, you'll only have one SVI open at a time. But because this is a layer 3 switch, when I create these, they will actually all be active. And so, because it's a switch, it doesn't do IP routing by default, but do that command, and it will. And then, of course, on the switch, we need to assign the ports to their VLANs. And so, of course, this is the trunk link between this switch and the other switch. And then again, port 10 for VLAN 10, port 20 to VLAN 20. And that is the config. That is enough for that switch to be a layer 3 switch. It's not very big, is it? So copy. Just that we'll have a lot more things to look at in this one because everything's on it. So, don't see any errors. Now, one thing I didn't show you, that command. Now, this is a bit of a strange one, actually. I wanted to make the port a trunk port, but when you do that, and it trips me up every year because I normally only do this about once a year, so I always forget in between. For this particular type of switch, you can't manually make it a trunk port because it's actually doing what's called auto sensing for the encapsulation type. Now, back in the dark ages, Cisco actually invented trunk ports and trunk links, but they didn't invent the .1Q protocol. They actually invented their own called ISL, which was inter-switch link. And so they had their own encapsulation system with tagging that allowed it to all happen. That's all very nice. So the very oldest switches from Cisco only supported ISL. Then there was a 5 or 10 years where they actually sold them that supported both. Once the .1Q standard came out, so of course .1Q was short for 802.1Q. So that's a tagging protocol. Once that was available, Cisco conformed with the standard, but they also had the old ISL as well for backward compatibility with older switches. And so you could actually choose your encapsulation either between .1Q or ISL. Now, switches these days, they don't sell them that support ISL anymore. And so you've got an option of .1Q or nothing. But they've sort of left a safety guard that they don't really need in there. And so the default setting is actually switch port trunk encapsulation auto. And because it was auto, it said, I'm not going to allow you to make that a manual trunk unless you set what type of encapsulation you want. And so I actually had to do that command, say, I'm going to use .1Q, because the only options available, if you do the question mark at the end of that command, .1Q or auto. So it only supports .1Q, but we have to manually do it. So that's a bit of a pain. Trips me up every year. But yeah, so I got to admit, 5 or 10 years ago when we had some older model switches getting about, you actually had to set that. But
Why does it work when you do auto, like, you have to specify, sorry, but...
It just won't, because it says, I want you to tell me what it wants, even though there's only one real option.
Right.
It's just the safety guard that's really just a hoop that you need to jump through. It's a pain. Someone in Cisco should probably look at that and go, this is a pointless activity. But anyway, so that's something you just need to do. Every year I do something like this, and every year I forget, I need to do the encapsulation. So yeah, if I'd done this command without that, it actually wouldn't have worked. I just would have gotten an error message. So anyway, so the rest of the commands are exactly the same as what we've done before. So of course this is a layer 3 switch now, so show IP route. And so we have 3 subnets for the 3 VLANs. Cool bananas. Show VLAN. So again we have VLAN 10 for staff, VLAN 20 for students, and VLAN 99 as a management VLAN. Okay, so that's that switch done. Now switch 2 here, I think I've only changed one thing. I think I used a different port for the trunk link between the two. I think the other one was G0/2, and yeah, I did 1 this time. So that's the only difference between this config and the previous one we did. So again, define the VLANs, do your port assignments, give it as SVI, done. Copy and paste. Again, no errors. All good. So show VLAN. Again, port 10 in VLAN 10, port 20 in VLAN 20, and VLAN 99 is there. All very happy. Now, I suppose I didn't actually look at the show run on this, did I? Not particularly different. So, of course, the IP routing command is there. Port assignment for 10. As soon as you do something, it actually does switch port no negotiate. So that's a good plan. Turns off the dynamic trunking protocol. That is a good idea. Same again for port 20 on VLAN 20. And of course, there's the trunk link. And so here are the 3 SVIs. And yeah, that's it. So
you can jump into that switch through any of those IP addresses.
Yeah.
And you'll get to basically the same.
Yeah, it'll be the same interface. Yeah. As in user interface, you won't be able to tell. Okay, so the addressing is the same on this. Ping itself. The host on the other switch, but same VLAN. Same switch, different VLAN. ART request is holding us up. Other switch, other VLAN. Router. This is the other switch. Yep. So it just, again, a switch being slowed up. So we have full connectivity. So I'm going to say router on the switch, router on a stick, works well. But of course the downside with it is all traffic between VLANs has to go up to the router, be processed, back down exactly the same link, and then to wherever it needs to go. So it's not the most efficient way to do it. So if you need higher performance, a multi-layer switch is certainly a better way to go.
PC10, the PC's on the right hand side, so we've got the layer 3 switch before they go back to there.
Yeah. So this one still needs to go across a trunk link to go. Even if you're pinging between these two, it would actually go there and then back again. But I'm going to say, in that same process, this would have gone up there and then back. So still more efficient.
And probably the setup is a little bit simpler.
Yeah. So that's multi-layer switching or layer 3 switching. And so basically that layer 3 switch, you can do most things that you can do on a router. It'll run routing protocols, it'll do a whole pile of things. The downside is that you normally can't get WAN interfaces into it. That's where your router shines, is the variety of interfaces you can put into it. Maybe not the number of interfaces, but the variety of interfaces. So that's pretty much it for VLANing. So are there any other questions at all?